Okay, so I discovered why it's always good to not do these things on the fly yesterday. If you remember, I was trying to create an alphabetical, a comparator that would sort strings in alphabetical order, and it almost worked. And the one thing that it wasn't doing that I wanted it to do was to maintain distinct strings if they were the same but had different case. So that wasn't happening, and that was because I basically stopped here. So the strategy is, and I mean, the reason this is important to understand for not so much for this in particular, but just in general, when the programming is about debugging, not writing code. I mean, there's a certain amount of effort that has to be spent on, figuring out how to make a particular method work and what a given algorithm it is. For most of what we do, the algorithms have already been figured out. In other words, there isn't very much new under the sun. I mean, there are a lot of really smart people that are coming up with new and fancy algorithms and stuff, but kind of as a blue-collar programmer myself, that's usually not me. And so it's just a matter, if there's something I need to do, it's often a matter of just finding out how to do it, because somebody has already done it, even if it's not in the same language. There are some fancy algorithms. I mean, in particular, for I'm trying to think of the last. Yeah, on a number of occasions, I've had to look up articles in the ACM, the Association of Computing Machinery journals, where they will periodically publish algorithms. Okay, here's how to do this particular thing. Here's how to create percentage quantiles for the student t distribution. I had to do that a couple of years ago for something I was writing, and I'm not smart enough to come up with one of those, but somebody was. I looked it up. It was in a bunch of pseudocode, so it just was a question of implementing that pseudocode in whatever language that I had available. And then I had to. So, programming is about debugging. Okay, so yesterday there was something that I wanted this to do, and it was doing almost all of it, but not quite. Again, notice that I was testing it a lot, and again, testing is so important. Let's see, where was I? In this case, we're just writing main methods. There are, unfortunately, things that I don't have time to get to in this course that are fairly important, though. There's something called unit testing, which is a very nice and effective way at the micro level of making sure that your methods are doing what they're supposed to. Haven't really been doing that here, but here, in order to test this, and I tell you what, I will comment out what I had not done yesterday, and then so here are kind of the tests. It's like I wanted there to be here 2 strings that are identical except for case, and I wanted those to be both in there. Here's another 2 of them. Again, these are kind of weird. I wanted to make sure that I had uppercase and lowercase ones starting with. I even had one where there were 2 uppercase ones, and it matched. The other thing that you need to make sure of is that if there's a partial match, so here this was a partial match of both this, and this, and is it going to show up at the right place? Okay, and what I was seeing was a little bit of that. Okay, so this one worked okay, but then notice that this triple capital A was not, was kind of clobbering the lowercase one. And likewise, I was only getting one Aaron, not the other one. And I wanted them both. Okay, so what did I do wrong? What was the strategy? The strategy was first to say, well, let's compare them, but ignoring case. And it turned out that, string has a nice method called compare to ignore case, which is going to return 0 if they're identical up to case, and 1 if one's greater and the other less. So that's kind of taking one step towards it. And so once I make everything lowercase, then I can sort them, and that's what I was doing here, according to the characters. So the fancy part of this was the fact that I first break it down into lowercase characters, and then go through the minimum. I have to go through the minimum of the length of those, because if I try to do it for one of them, then and I run out in the other, I'm going to get a null pointer exception, or array index out of bounds exception, or whatever. So then I subtract the characters, and then that's my result. And then if that ever comes up not 0, then I know that there's going to be a difference there, and so I can break with that. Now here's the problem. So let's diagnose what was going wrong. It wasn't doing what I wanted it to do. Why? The why was, let's take just a simple one like the AAA, uppercase and lowercase. So what was happening with that? This is going to turn out to be 0 here, because once I make them both lowercase, once I make both AAA's lowercase, this is going to give me a 0. And then when it runs through all this, it's still going to be 0. So this is going to return 0. But I don't want it to do that. And I'm okay saying, okay, the AAA is going to be ahead of the lowercase a, because that's the way that the Unicode and ASCII both work. Or Unicode, because Java's Unicode. It was actually one of the first languages to do that. So say, okay, if you make it to here, and it's still 0, remember I turned everything into lowercase. If you make it to here and it's still 0, it could be that they're still not exactly the same because of case. And so that's what the final little piece that I was missing yesterday, and it was just a brain fart. If I make it to here and the result is 0, then now I can just sort of compare them normally. And if they're still 0, that means that they're exactly the same. But now if they come up and they're and there's a difference, then it'll sort it according to the original way. In fact, just to kind of put an extra point on that, let's sort of add a second Aaron, and so there should only be one of those. Okay, so now with that, I'm getting everything. So I get this. I get both of the AAAs. I get only one Aaron because with a capital, but I also get the one with the lowercase, and I get the different Henrys. Okay, so that's what was going on. But the point is that regardless of what you're working on, you're trying to make a method work right, to put tests in it and say this is how I predict, or I want this to come out, and if it's not, then step through and see, okay, what the heck is going on here? So that's an important lesson. Okay, so now today, if I can find this. There we go. Okay, so today I'm gonna delve. We've been talking about collections, lists, and sets. So we have 2 types of lists, 3 types of sets. We have array lists, linked lists. We have hash sets, linked hash sets, and sorted sets, and that is tree sets. And for like in the blackjack example, I felt that you could use either a hash set or a linked hash set. You could even use a sorted set if you wanted. For that, I felt that a linked hash set would be more useful than the other ones, because that way you could see and verify that in fact the points were being done correctly, and if you watch the sequence of the cards that were being hit, you could see that they were following the right rules. Okay, so that's. However, again, I haven't looked at all of them yet, but if you wanted to do a sorted set, that was fine. If you wanted to do a hash set, that was fine too. It would work either way. Just for me, that would be one instance where a linked hash set would be useful because the order that you were getting the cards was important. And then yesterday we talked about maps. And so we saw that maps are a generalization of arrays, and today we're going to kind of apply some of that stuff to reading files and just doing a little bit of very simple processing of what we're reading. So we've already seen a little bit of this, but I'm going to talk about it a little bit more. The file class, so the file is an abstract or conceptual representation of a file on your computer. That's the orientation. Whereas URLs actually can refer either to a file on the computer or to something that is on the internet. And so we're going to look at reading a text file and then splitting strings according to certain criteria. And that takes us right into this concept of regular expressions, which we're going to dip our toes in a little bit, and for which there's a handout. So an instance of a file class refers to a file in a system. So a file object, it may refer to a file that either does or doesn't exist. And so the question, why might it be useful to have a file object that refers to a file that doesn't exist? Does that make sense? I mean, on the face of it, maybe it doesn't. Can you envision why you might want that?
If you have some kind of program that's supposed to be constantly updating based on the output of something else, and like part of it is just looking for like a certain naming convention of the output of that other program to feed your own.
Yeah, that's definitely one use case. I mean, it's that is definitely a use case where you have a program where it's looking for the output of another program. Actually, there are a number of things that I'm working on right now that are like that. And so one strategy is to kind of keep pinging. Okay, is that file there yet? Is it there yet? Is it there yet? That's not the most effective strategy, but it is a strategy. Any other thoughts?
Be a convention to, hey, it doesn't exist, make a book, make a text file to fill information. That's an output.
Yeah, what if you want to just save a file? Before you save the file, it doesn't exist. You open up like a Word document. You create a Word document. The file doesn't exist on, well, I mean, it's somewhere in they kind of put it somewhere, but before you save it, it doesn't exist yet. So, and so as we'll see at some point, maybe not today, But if you're writing a file and it doesn't exist yet, then we can use the file object to do that, and we will. The other thing is that a file, let's see, it doesn't, okay, different constructors. So if I want to create one, I can just give it a path name. The typical use case of that is, again, the user is going to save a file, and when you go to save a file, you know, it may provide a default name, but typically you want to type in the name of it. And so that will lead to a constructor, something like this. Like if you're saving a file, I can instantiate a file object and then give it the name that the user has created, including the path to where it is. The second constructor is that, actually the second two, is if I want to create a file in a particular directory, then this is really the best way to do that. In other words, when we start working with files, we'll kind of see some of that. If I have one of these file objects, there are all kinds of useful methods. So I can refer to the file in a relative way, or I can refer to it in an absolute way. My experience is that referring to files, at least from the command line with a relative path, is the most useful. Why? Because it's less typing. In other words, if I want to refer to a file in the same directory that I'm in, then I just give the name of the file. If I want to refer to one in a directory one below where I'm running the program, then I can just give it the name of the directory and then / the name of the file. However, once it's there, that file object knows exactly where it is on the file system. So get absolute path is an absolute location on the file system. I can also say, since a file either could exist or not, I can say, do you exist? In the context of writing a file, why do you think this might be a useful thing for a file to know about?
Duplicative name. They have to be independently named, so something already exists of the same name, you have to change it.
Yeah, or what if you want to overwrite it? So if you're about to clobber another file, then as a user, well, what usually happens these days? Like if you're writing a Word document and you say save as, and you're saving it as a file that already exists, what does it do? It says, hey, you're about to overwrite. Are you sure? Are you really sure? Editing programs didn't always do that. Just back when dinosaurs ruled the world, after many people were tearing their hair out because they accidentally clobbered a lot of their work, they realized, well, okay, let's have at least a confirmation of that. A file object can refer to a directory as well. It can either refer to a file, like a file, or it can refer to a directory. So this was actually kind of I think a useful thing that they did on this. And I can say, are you a directory? Or are you a file? Again, Booleans on this. And because every file is located somewhere in the file system, and every directory can also be a file, if I have a file object, I can get its parent file, and that can be useful. Like in the example you were saying before, well, okay, what if you have to kind of rename things? Well, instead of overwriting this file, I want to write it, but I want to write it to the same directory as this other one. Well, this other one can tell me what directory it's in, and so then I can use this constructor to say, okay, put it there. And then if it's a directory, I can actually list the files in there, say, give me all the files in your directory. And they even have something called a file filter, which means give me all the files that meet this criteria, like give me all the Excel files or give me all the Word files. Now, it isn't quite that sophisticated. It's a little, this is kind of a throwback to the old days. But the filter will typically work on the extension. So if I have a file whose extension is .docx, then I assume it's a Word file. That doesn't have to be the case. You can name a file anything. But okay, so those are some things you can do with a file. There's a thing called a URL now. And a URL can be either local or on the internet, and that's because the criteria for what a URL can be is specified by the whatever that body is. Specifies a number of different protocols, and so one of the protocols is a local one. So if you have like file : / that can be a local file. Or if it's an HTTP, and there are other ones like FTP and whatever. A lot of these kind of go back to the old days where there was all these different formats. And before the World Wide Web, there was the internet. See, we associate the internet with the World Wide Web, but the World Wide Web is just one way of accessing the internet. The internet is actually something else, which you are all learning about in your network class, or haven't? Yeah, so you know all about that. So the Java URL object can be used to read a file on the internet or locally. So before we get to that, let's see an example.